What we're going to do today is look at a very basic sprinkler system in this building, and I'm going to show you some of the enhanced modelling tools that we have to save time whilst connecting up sprinkler heads to pipework systems, and also show you the calculation functionality that we have within the software to enable you to calculate sprinkler systems to various codes of practice. So first of all, very quickly, I'm just going to show you this already preset, sort of half-finished sprinkler system that we have here. So you can see these little warning markers here. They're just standard Revit ones to show my sprinkler heads aren't connected, which you can see here on the right hand side. And what we have is just a basic sprinkler system coming into this hall, and some of it's connected and some of it isn't, and you can see there that we've got connections to sprinkler heads coming off these various pipes here. So these obviously is quite laborious to do in Revit to connect all these sprinkler heads up, to first insert them in fact, and then in the right quantities and the right spacing, and then connect them up. It takes a very long time in Revit, but we have some automatic sprinkler connection tools which I'm going to show you. This one was created using the sprinkler connection tool as well, but I'm just going to show you how this one and this one works, which is I'm going to show you the inline and the grid function there. So first of all, let's have a look at installing some sprinkler heads. So I go to install product, and then I can choose from here sprinkler device in this browser, and I'm not going to show how this browser works. That's a different webinar, but this is one sprinkler head that's in the data set which I'm going to choose. Press OK, and I get a floating toolbar. I can obviously insert as usual MagiCAD functionality one by one, or I can do like an array. So I'm just going to draw an area. In this case I'm going to draw a number of instances spaced with 3 rows and 10 columns. Of course you can customize this however you want, and then in here I'm just going to draw the area. It's just one of many options of inserting sprinkler heads, but again this is not for today's webinar to show you this functionality. And there's some sprinkler heads. Of course you could change that to 4 rows and press update, and yeah, there's 4 rows now in there. So you can change it to suit your system, or you can do it to distances between sprinkler heads if you know that as well, by controlling it with these. And then once you're happy with it, you press apply, and then I've got a floating toolbar here which shows you some information about the sprinkler heads. So of course you can choose the system type and the actual system you want to put it on. In this case it's a fire protection wet for sprinklers, and it's my SPR1 sprinkler system. And then area of coverage, you can choose and enter a figure into there, and then required flow density. If I change that, you'll see that it automatically calculates the required pressure level from the flow density in this floating toolbar. It updates it automatically. But if I put 5 in there, but if I want, 1000 millibar, I can type it in there and it'll overrule that. And what MagiCAD does in the calculation, it will actually take the highest figure of the two, so the greater of the two figures there. So it's either the manually entered one if it's greater, or the calculated one. So if I increase my required flow density to 10, you can see that my required pressure level now increases to nearly 2000 millibar, and it overrides the manual one there. So if I go back to the original figure as 7.5, let's say, it's the same. And if there's an option to change the orientation of the sprinkler head, you can do that there. So if you're happy with it, just press apply, and you'll see that now inserts the sprinkler heads with all those properties. Just for your information, if you click on a sprinkler head, the properties are all instance parameters in the properties here, so you can see you can change the sprinkler head area of coverage, density, things like that in there anyway. So you want to change it after the event, then of course you can, no problem at all. So that's the process for inserting sprinkler heads, as I said, very easy to do. So when you want to create arrays in rooms or things like that, it makes it a lot easier than the standard Revit, just clicking and trying to choose your sprinkler heads in the area. So next one, let's look at connecting these up. So the first one I want to show you is, say, connecting these sprinklers that are either side of this pipe. So go to sprinkler connection tool here, choose the type of connection. So I've already done the inline one. You can see that's already been done there. So I'm going to do the antenna type, and it says select sprinklers. So let's drag a window across my sprinkler heads, and it'll filter it automatically. Then I want to click on the pipe where I want the connection to be made, like so, and I get a little window showing my sprinkler connection proposal, and you can see that it's got a little preview here. It shows the sprinkler heads coming off the mains pipe. It shows you dropping down off there, and you can change these heights and offsets in here by level, by a constant offset like that. And if you want to, you can also change how the sprinklers are connected to the pipe. So if I wanted to put an offset on the sprinklers, something like this, I'll just show you a quick preview of how this works. So it's just going to reconfigure the sprinkler head layout. If I click on there, you can see, obviously it's done, put something crazy in there. I'll just refresh that, and you can now see that it will reorder the sprinklers with this offset of 100 millimeters horizontally and 150 vertically, and you can see there that it now loops it over off the pipe like that. So it's a very, very, very quick way of arranging your sprinklers. In Revit, that would take you so long to complete that task, and it's obviously just fairly automatic in this. So if you're happy with your system, you just select the solution that you want, and then just press OK, and then it will draw that. Press OK, and you can see now in the 3D view that that's the sprinkler arrangement. And then what I'll do now, I might actually do a grid system. So that's when you have sort of two pipes either side of a system. So I can select that one, press OK, and I'll choose my grids either side. And again, we can see the preview in here, however I want to do that. I think I'll do it like this for this grid. So not all, you can see there I've got some piping errors. I mean, not every solution is obviously possible in every single configuration. So there's that one there. Then press OK, and there's my grid system already shown there. So you can see that what I've done is created a sprinkler system based on the antenna, the inline there, you can see, and also the grid system, which is there. So that's all. I hope you can see all the time-saving benefits of using that. So once you've done that, before we proceed into any sort of calculations, I just want to show how you can create some nodes, which is like reference numbers, so you can see these in the system later when we do the calculation. When it refers to heads and pipe sections, then when we put all these numbers on there, they'll become more relevant to the you can see there's all the node numbers on there, and they'll become relevant to the calculation later. So now we've done that, what we need to do in terms of a calculation is create a sprinkler area. So the sprinkler area itself are these boxes. You can just about see them. I'm just going to highlight them now. So there's one, there's a sprinkler area, there's another one here, there's another box you can see there, there's another one here as well around this section. So what the sprinkler areas are defining the sprinkler heads themselves as part of a network of the sprinkler piping system, which will be used to determine the sprinkler calculation. So obviously, as a sprinkler designer, there's an element of experience and judgment which will determine the sprinkler areas, and these are to define the most onerous of the sprinkler system, so it's maybe the weakest sprinkler head or the estimated index run, the furthest sprinkler heads away from the pump, or anything like that. So what you're trying to do is define the area, or a collection of areas which you want to focus on. Otherwise, you'd have to draw sprinkler areas around everywhere in the project and try and work it out like that, which isn't really helpful. It's you're meant to be using your judgment to define these areas. If you choose a sprinkler area from to create a sprinkler area from this calculation here, it's called sprinkler design area, all you do is choose a name for it, a system that you want to put it onto here. That's an existing Revit system, of course, a hazard class, and choose your offsets, and all you do is press OK, and then you just create a new sprinkler system, maybe a box or freehand, it's up to you, and you just create that sprinkler area like so. But once you've created the sprinkler area, that will encompass the sprinkler heads within. It's almost like a 3D bounding box, effectively. So that will encompass the sprinkler heads within that area. And it's worth noting, if you create a sprinkler design area with the same name, so you can see that this one, if I click on that, it's hall 3, and if I click on that, you can see that it's also hall 3. If it's the same name, it doesn't matter if you got 1, 2, 5 or how many sprinkler areas. If they're the same name, the calculation tool will actually detect this and include those sprinkler heads within the calculation of that sprinkler area with the same name. So even if you're in different parts of the building, if you're unsure about 1, 2, 3, 4 different sprinkler areas, so you can create 1, 2, 3, 4, 5, how many of the same name, and then the calculation will look at each of those sprinkler heads in each of those areas with the same name as part of the same calculation to then determine the weakest sprinkler head in that design area, even if it's in different places in the building. So it does give you some flexibility that way. And then if you choose another sprinkler area with a different name, like so hall 2, then that would be a different calculation for that sprinkler area itself. So once we've defined the areas, what we need to do now is maybe do some pipe sizing before we do any pressure calculations. So go into the data set, and you can see size method of sprinkler. You can create as many as you want, and in here you just say the number of sprinklers on the network, and then the maximum pipe size serving that maximum number of sprinklers at any one time. So just press OK once you're happy with that. I'll just return to that actually. If you want to redefine it, double click, or change the figure, or you just press add and add a new one in there. So once this is done, we can then go to calculation and go to sprinkler sizing, and you can choose to do a branch or a network all at once. It's up to you how you want to do that. Choose your sprinkler sizing method, press OK, and let's say that I'm just going to do a sprinkler, say for a branch. You just pick an area, just hit down here, and you get a report you can see showing you all the different sprinkler heads and pipe work connecting each one, and then the number of sprinklers on that branch and the proposed size of that. So it's quite a basic but very effective sprinkler sizing system. And then once you press OK, it will now resize the pipe work, serving all those sprinklers as required in the calculation. So you can see it's now resized all my sprinkler pipe work. You can see there how it's got reducers all over the pipe work now to determine that main pipe size, and so you can see there how that works. And once I've done the sprinkler sizing function, we can now look at some of the sprinkler calculations. So if I go into the Common tab, just so you're aware, in Settings, you can see here that we have a Project tab, and in there you can have an automatically selected sprinkler calculation. So you've got EN 12845, CEA 4001, MFPA 13, BS 9251, and Uni 10779. So you can choose as default any of those. I'm just going to choose the BS 9251 in this case. And then once that is selected, we can then go back to the piping tab, go back to sprinkler calculation this time, and select a pipe from the network. So let's choose this. And it will now produce the calculation based on the settings that we can put into this dialog box. So again, here's the design areas that we're concentrating on. As I said before, we've got two. We've got one here in this design area here, and then these two design areas, but effectively one design area. So let's look at hall 3. Choose the standard. Again, you can, this is defaulting to the one from settings, but you can change it here. The method can be Hayes and Williams. You define that in the data set in the pipework series that you're using, or it could be Darcy Wyback, and you choose your conditions for that. So I'm going to Hayes and Williams in this case. You can choose to balance the minimum pressure. If you had a pump, you can balance the pump pressure, which grayed out because there's no pump. And also you can put your own feed pump pressure in there as well, if should you wish to. But it's always best to balance the minimum pressure first and then put your feed or pump pressure in based on this minimum pressure first. And then finally, a few tweaks here and there. You can actually ignore branches shorter than a certain size when it comes to the calculation, and you can also choose where welded as opposed to threaded pipes start at a certain size for K factors of bends. And you can also have any warnings of high velocities if you want to do that as well, and put a figure in there. Press OK, and now it's doing the calculation. And you'll see here we now have the calculation report, so you can see it gives you the software version, project, design areas, hazard class, the model, the calculation method, standard or code, some fluid data. So this is like a summary report sheet, and some of the key things I want to touch on. I can't go through all this, I haven't got the time to go through this in detail, but some of the key things is weakest sprinkler head, number 37, and the node point. You can't really see it on the screen now, but I know that's 37 there. We can zoom. That's why I put the node numbers on there earlier. The feed point, the design area, the pressure at the weakest sprinkler is 1,108 millibar, which we knew that because that's what we put into the calculation. Number of iterations, we've got the Hayes and Williams factor in there, and then the calculation results. The pressure at the feed point, that's the minimum pressure we need to achieve the pressure at the weakest sprinkler head. There's the flow rate that we need. There's a flow at the weakest sprinkler head, etc., etc. So you can see all these figures in there stacking up exactly as we thought it would be, with the flow density and area of coverage. Then we can move on to the sprinkler results, so we can actually see the individual pressure and flow at the sprinklers themselves. And as expected, the 37 weakest sprinkler head has the actual pressure at the head exactly the same as required, so them two match. And you can see that the other sprinkler heads have the same pressure required because that's what we prescribed earlier. But obviously the pressure it actually increases as we go back through the system, as you'd expect. And you get the area of coverage, the flow density, actual and required, and things like that. So you can interrogate any of that for any of the sprinklers at all. Then we have the system results, so you can see that this is showing the C factor, the K factors. This is just the hydraulic pressure calculations effectively, with all the bends, T's, other fittings in there, through to the all the section numbers notated in there, and then the equivalent length values taken into account for T wrenches and 90-degree bends, and you can see the different sizes and have different K factors. So if you're happy with that, you just press update the model, and you can see that now increases the well, not increases, I suppose, adds the pressure into all these different pipes. And you can see if you click on there, all the information that we had, like flow and velocity and feed point pressure, is all indicated in there. So you can tag all that in your drawing should you wish to, just using standard Revit tags as normal. Don't think we've got anything set up to tag it with, but if you wanted to tag something, that's your basic pipe size tag. How you want to do that, you can add that for pressure, velocity and things like that. And as I said before, there's the node numbers. So there's your nodes. Weakest sprinkler head was number 37, and all the pipe sections are also indicated in here, so you can interrogate any of that. If you want to hide the numbers, you can reset node numbers, you can show the node numbers. You can customize that however you want. It's perfectly up to you. So on your model or in your plan, you can have the node numbers on some sort of engineering checking view, then you can turn all the node numbers off should you wish to. It's all, like I said, perfectly up to you. As you create different sprinkler areas, then obviously the node numbers change because you need different calculations in each of the areas. So it's a good idea, good practice to update the node numbers as you run each sort of sprinkler area calculation. So, well, I think that's the summary of the sprinkler package, covered fairly quickly, but I think quite thoroughly, to give you an idea of the modelling tools and indeed the sprinkler calculation tools. That's the end of this demonstration video. Thank you for your time. You can see on the screen now ways of getting in touch with us in the UK by email or phone. So please get in touch and we can provide any more information you require. Thank you very much.